You cannot have a conscious thought and say, I want my heart rate to be faster or slower. You cannot do that. You cannot make your blood pressure go up or down by thoughts. Your yoga teachers might think they can do that, but they cannot. All right? Your sensei might think that they can control these things, but they cannot. Can you put yourself in a relaxed state? Calm yourself. And would your blood pressure probably come down a little bit? Would your heart rate come down a little bit? Yeah. But not because you had a conscious thought to do it. You put yourself in a particular environment that affects the stuff in your body. Can you have an exciting thought right now? You make your heart rate go up. Yes, you can. What's doing that? Your autonomic nervous system is doing it. I'll show you how it does it Monday, not tonight. All right? You do not control any of that. It just doesn't work that way. Okay? But again, what you do, what you think, what you experience, right now, if a big rabid dog comes running through that door down the steps, everybody's heart rate's probably going to jump. Why? Because your autonomic nervous system is going to make it do that. Okay? Automatically, by the way. And that's one of the ways you can think of autonomic. Automatic. It's stuff that just happens automatically. It is adjusting to the environment that you live in and that's inside of you. A lot of it's homeostasis, by the way. All right? So it's involuntary. So far, what have we done? We have controlled visceral cells. Visceral cells, motor output from the brainstem and the spinal cord. It's involuntary. We'll get back to this in just a second. The effectors of motor output, cardiac muscle, smooth muscle, visceral cells, 2 efferent motor neurons between the central nervous system and the effectors. That's what we've done so far. Now what we're going to do is this last part. Preganglionic, postganglionic. The first one and the second one. So we're going to name it. And we're going to talk about exactly what it means. So the first one here is the preganglionic neuron. The second one is the postganglionic neuron. We'll put the word neuron in there. And it's the same. This one's the pre, this one's the post. The pre is myelinated, the post is not. We can clearly see that. By the way, if you haven't drawn up into this point to study for exam, this would be a really good time to start. Okay? Why? Because that picture right there is pretty much what, about 20, 30 lines in your notes? Easily? You can clearly see the preganglionic neuron is myelinated, if that's the way you draw it. You can clearly see that the postganglionic neuron is not. Same thing here. You can clearly see that these motor neurons, those are motor neurons too, we just don't call these preganglionic or postganglionic, you'll see why in just a second, are myelinated. You can see they release acetylcholine. You can see the nicotinic receptors. And we're going to get to the receptors here as well, just not yet. All right? So again, if you haven't drawn up into this point, boy, would this be a good time to start. Okay? So what does it mean, preganglionic and postganglionic? We know what pre and post means, right? Pre means before, post means after. You guys know what a ganglion is, do you not? What's a ganglion? Somebody define a ganglion for me. It's a group of what? Cell bodies. Where? In the peripheral nervous system, correct? A bunch of cell bodies grouped together in the central nervous system is called what? Not a ganglion, but a nucleus, correct? What's the same thing as a nerve in the central nervous system, by the way? A tract, right? But we're talking peripheral nervous system right now, so that's why I use the word nerve and not tract. And now I'm going to use the word ganglion and not nucleus. So, this preganglionic and postganglionic name has everything to do with the ganglion. And so we're going to draw it. I'm just going to pick, I don't know, the thoracic region. We'll do this really quick and then we'll take a break. All right, so brainstem, cervical, thoracic, lumbar, sacral. I could have picked the brainstem, the thoracic region, the lumbar region, instead of that. I'm just choosing the thoracic region, okay, to draw it in this area. I'm going to draw little circles here. Not too many. I don't know. 5. Okay? Those 5 cell bodies which is what those are all grouped together. So what did I just circle? What is that? That is a ganglion, correct? A ganglion is a group of cell bodies. And if your circle is a cell body, that by definition is a ganglion. Okay? Now I'm going to draw cell bodies in the thoracic region. I'll draw 5 of them. And I'm going to have this cell body synapse with that. I'm going to have this cell body synapse with that one, and this one with that one. And I'm going to put myelin on these. You see where this is going already? What the hell is that? All right. Now what I'm going to do is I'm going to put the word effector here, effectors, because there's 3 of them: cardiac muscle, smooth muscle, visceral cells. And I'm going to have these cell bodies innervate, synapse with the effectors. So that's a ganglion. These are neurons that are happening before the ganglion. So those are your preganglionic neurons. Your preganglionic neurons are the neurons that come from the central nervous system. We can clearly see that. Not all, by the way, not all neurons that come from the central nervous system are preganglionic neurons, because these do, and they're not called preganglionic neurons. You need a ganglion, okay? But in the autonomic nervous system, those neurons that arise from the central nervous system, brainstem, spinal cord, are the preganglionic neurons, okay? And these, the ones coming from the ganglion, are the postganglionic neurons. It's all anatomy, guys. And the postganglionic neurons are unmyelinated, as we already know. So we drew it. The preganglionic neurons are myelinated. We already knew it. So we drew it. So when it comes to preganglionic and postganglionic, you have to have a ganglion. Okay? Let's take a little bit of a break. When we come back, a little bit more on this, and then we'll keep going.